Greetings, it's me, Miss Wesley, one of my favorite parts of the day because we get to talk trigonometry. I am joining you at the top of Trig Packet page 16, where we actually began to talk, and we've talked about the unit circle before, but you just can't talk about this thing enough. So I'm looking at a blank slate, and believe me, get your pens and pencils ready. We're going to label up this entire circle, get a lot of degree measures and coordinates on there. A joke to start. Why wouldn't you want to trust your math teacher if she's like walking around with a piece of graph paper in her hands? Well, because she's probably plotting something. It says at the top, fill in the degree measures and coordinates at the points corresponding to special angles on the unit circle. I'm going to reiterate myself again. We have seen this thing before. We've used the unit circle, and it's called that because it has a radius 1 unit, to find the exact values of trig functions of quadrantal angles, like 0, 90. And speaking of which, you probably already have those on your picture, right? 0, we labeled 90. 180 is a classic. 270, and then full circle. That's a good pun. We'll go back to 360. And we even went further than that. We started putting some coordinates of special angles on this picture too. So 30 degrees, I'm going to label here. Then go 15 degrees beyond that. We had a 45 and a 60. Can you keep it going? Keep that pattern going straight across. So every kind of big chunk of this, you're adding 30 degrees to it. So your next special angle is a 120. Why is 120 so special? Well, each one of these that we're about to label has a reference angle that's going to be one of these three guys. And it's going to enable us to get an exact value of its trig functions pretty quick. This is a good time saver. So 120, what would have a reference angle of 45 degrees? If you want to, give yourself a dotted line straight across. Because we're going to talk about right triangles that get formed when you drop perpendiculars, and you're going to see that 135 is closely related to 145. And straight across from 30 degrees is going to be 150, right? 150 has a reference angle of 30 degrees. We already had 180, and then I think I remember putting 210 on this picture, right? But what's beyond that? What would have a reference angle of 45 degrees and be in quadrant 3? Well, you're done at 225 degrees. Remember that number. It'll come up often. 240 is the next one. We add 15 to that to get to 240. 270, straight across from 240, it's going to have the same. What is the reference angle for 240? Well, if you go 60 past 180, you get there. So a reference angle of 60 in this quadrant would be 300. Right? So you're adding 30 to 270. Can you add 15 to that? We'll get a reference angle that matches with a 45 degree reference angle here. So you're almost a full 360, but 45 less than that is 315. And add 15 to that. And we'll get our last special angle in quadrant 4, which is 330. And then you're back to 0 or 360 degrees. The reason these dotted lines are going to help is because of what we're about to do. The second part of the instructions say, fill in the degree measures and the coordinates at the points corresponding to the special angles. So we know some of these points already. We know the points at the quadrantal angles are what you see in this little diagram here. So I'll just write it right here, 1 comma 0. You don't have to memorize it. You know you're traveling out a radius of 1 and you're going up nothing. Up at 90, let me circle it because it's quadrantal, 0 comma 1. Remember the sine and the cosine are there. At 180, you've got negative 1 comma 0. And 270, right? 0 comma negative 1. It's good to have those coordinates listed because then you've got access to exact values for the sine and the cosine right in front of your eyes. Okay, now let's go in and do something brand new. Can we label coordinates at these three special angles in the unit circle in quadrant 1? You might already have a perpendicular dropped here where you made a right angle for a 30-degree reference angle. If theta is 30 degrees in here. Well, think about it. We know this because we've made tables and we've been practicing with it for the past couple of days. What should the y and the x value be? What's the sine of 30 degrees? Exact value of the sine of 30 degrees is only 1/2. 30 is the smallest angle in this right triangle, so it's across from the smallest side. So by 30 degrees, I'm going to put the x coordinate a half. The y, oh, I did that wrong. the y coordinate a half, right? The sine of 30 is going to be a half, so I'll make that 1/2. How should I change the cosine? I was about to ask you the x coordinate. Well, you're coming over. The exact value of the cosine of 30 is square root of 3 over 2. So you're going out further than you're coming up to make that angle, because square root of 3 over 2 is about 0.866, which is much bigger than a half, which is only 0.5. So these two, this x and this y, represent the coordinate, the ordered pair, at the point on the unit circle with a 30-degree reference angle that'll hug the x-axis. This is the same exact shape. The reason this dotted line goes straight across, and I'm getting ahead of myself a little bit, but I could actually label this quadrant 2 set of points right now. It's going to, just like 150 has a 30-degree reference angle. So it's got the same numerical x and the same numerical y. If you were to create a right triangle, right, its y is going to be a half and its x is going to be square root of 3 over 2. But aren't we in a quadrant where the x should be negative and the y should be positive? If I think A, S, T, C, keep the sine, the y positive, change the cosine, the x, to a negative value. Now let me go back to get just fill in these other coordinates for the quadrant 1 special angles. How about 45 degrees? What are the sine and the cosine of 45 degrees? They are exactly square root of 2 over 2, square root of 2 over 2. I know this is going to make the picture even more cluttered, but if I had a right triangle here, it would be an isosceles right triangle. This length would be square root of 3 over 2, and that other leg length would be square root of 2 over 2, is what I meant to say. And then let's fill in 62 while we're at it. If you made a right triangle for 60 degrees, it would have, because sometimes I mix up, does the 1/2 come first or does the square root of 3 over 2 come first? Well, think about a 60-degree angle right here, and you have a shorter x side than you have the y side. So the shorter side is going to be the 1/2, the x, and the longer side is going to be the square root of 3 over 2, the y. I already jumped the gun and talked about 150's coordinates numerically matching up with 30's coordinates. Can you do the same thing with 45 degrees and 60 degrees? Absolutely. For 45 degrees, it'll have the same exact coordinates numerically as 135 does. Square root of 2 over 2, square root of 2 over 2. I just have to be careful to be thinking that I'm in the S quadrant where the cosine is going to be negative, the sine stays positive. And can you do the same thing with 120? Link it up to the angle that's across from it, but make the x negative. Negative a half, square root of 3 over 2. We are halfway to filling out all the coordinates around this beautiful, dazzling unit circle. Let's keep going, right? You can relate, I'm up to 210. 210 also has a reference angle of 30 degrees. 210, 30 degrees, 150, and which other angle do you think are going to be linked? 330. The ones I just circled in blue all have reference angles of 30 degrees. You would be forming the same size right triangle for all 4 of these guys because of their reference angle of 30. So what I'm going to do is, let's link it up. 150 degrees, we use the square root of 3 over 2 because you're coming out further than you're going up or down in this case, so a 1/2 goes second. How about let's make sure we're in a quadrant where A, S, T, both the tangent, so both the y and the x are going to be negative. Visually, we can see that too. So for all these angles within quadrant 3, let's have a negative x and a negative y. Let's link 135 degrees to 225. 225 also has a 45-degree reference angle. So let's use negative square root of 2 over 2 and negative square root of 2 over 2 for those coordinates. Sorry, that's a little bit sloppy. How about 240? I'll try to be neater there. What's going to help you with 240? Let's say I was going back to quadrant 1 and picking which of these angles is going to be helpful. Pick the one that has the reference angle of 240. 240's reference angle is going to be 60 degrees. Use these coordinates, or use the coordinates you use for the 120-degree angle. That works too, which is a 1/2 coming first, square root of 3 over 2 going second. In this quadrant, like we said, they've both got to be negative. Okay, that should do the trick. Now we're on to the final quadrant. 240 is very much linked to 300. They both have the same reference angle of 60 degrees. So same order of coordinates, the 1/2 first, the square root of 3 over 2 second, but which is negative? Well, we're over positive on the x, we are negative on the y. Let's make the y negative. 315, I always find it kind of quick when you're doing a 45-degree reference angle because it's not much to think about. It's the same number twice. But again, we are in a quadrant where, what is it? The y has to be negative. So we can do that for 315. Last but not least, 330. 330 is going to be just like 30 degrees. You're coming out further than you're going up or down. And technically in this one, we're going down. So we'll keep that y negative. Be proud of yourself. Why don't you just behold the beauty that is the unit circle so far? And in the days to come, believe it or not, we're going to put a little bit more labeling on this. So why did we take the time to do all that labeling? Well, I'll tell you why. You probably have a little bit filled out already in this box, but let's go back to those trig function definitions. The sine of theta definitely equals y over r, but we talked about how in the unit circle, r is just 1. So the sine is the y coordinate of all these points we just wrote down. The cosine is going to be the x coordinate. Sometimes I remember this by thinking, and I've said this before, use the vowel sound, psi, y. They have the same vowel sound. Cosine goes with x, and tangent's just what it always was. Nothing has changed. No shortcuts, y over x. Ones we didn't fill in before. Cosecant is going to be the reciprocal of just the y. You can call it 1 over y. Secant, you're going to flip the cosine or flip the x value. And what is it? Cotangent, right? Reciprocal of tangent, so x over y. So it's definitely a lot easier not to have to think about an r value that you're dividing by. Let's say, for instance, I want to wow my friends and give them, quick, what's the cosine of 60 degrees? Look at the unit circle, go to 60 degrees on the unit circle, pick me the x value. Tell me, cosine's going to be a half. I knew that right away. What if I was tricky and I said, what is the cosecant of 30 degrees? Go to 30 degrees, think cosecant. Which one is that? I have to flip the sign or flip the y. You're going to say it's going to equal 2. And what's even cooler is now that we've taken the time to look at the other angles and the other quadrants, I could do anything. I could go to 225 and give you the sign. Go to 225 degrees, sine of 225 is going to be that y. It's going to be negative square root of 2 over 2. Quick, what's the cosine of 300 degrees? No problem. Go to 300 degrees, give me the x value. Give me a half. So what I don't want to have to do is every single time I try to solve a bunch of exact value problems, I really, as much as I love the unit circle, I don't want to have to draw and label the whole entire thing every time. So I want to show you, I'll start showing you today, that all you really need is quadrant 1 of the unit circle as a shortcut to figure out all your special exact values. So we'll fill out things in this, I call this like the Trig Toolbox in a way. I'll just put Toolbox here, because it's got like a bunch of shortcuts and cool little hints for ideas we can use to get these exact values. Let's look at cosecant of 30 degrees first. Well, 30 degrees, notice in this first quadrant of the unit circle, the same values from our table. Remember that pattern? Everything's over 2. And then you had some sort of like 1, 2, 3 in the table, and then a 3, 2, 1. Well, the same thing works in the coordinates of the unit circle. For the sine of 30, it's a half. So the sines, the y's, are going to count up. 1, square root of 2, square root of 3. There's your pattern, same pattern from the table that we've been using. The x's are going to do the opposite. They'll go square root of 3, square root of 2, square root of 1. So just 1. And if you want to, you can plug in zeros, coordinates 1, 0, and 90, 0, 1. Really, for the quadrantals, I would just be filling out all 4 of them. 1, 0, 0, 1, negative 1, 0, and then what's the last one? 0, negative 1. But watch how cool this is. For cosecant of 30, no problem. Go to the y, the sine. It's going to equal 1 over the sine of 30. We kind of already knew that was a half, but we can see it here from that coordinate of the unit circle and call it a 2. Flip a half. Cosine of 225, 2 ways you can get this. One way you can get it is you can look at this beautiful unit circle we just filled in. Go to 225, pick the cosine, the x value, negative square root of 2 over 2. So I'll write that so we don't forget about it, because we might as well reap the benefits of having drawn out that entire circle. If you don't have the whole circle in front of you, no big deal. If you just know about quadrant 1 and you know that 225 has a reference angle of 45 degrees, this is equal to the cosine of 45, but it's negative because you're in quadrant 3. And you get the same exact thing. Just go to 45, pick the x, and turn it negative. Let's do tangent of negative 60, and let's pretend like I just have this picture at the bottom. What quadrant are we in? Negative 60, quadrant 4, ASTC. So I know my answer is going to turn out negative. What's the reference angle? Well, it's 60 degrees. I'm going to look at this little unit circle quadrant 1, Tangent is the y over the x, so negative square root of 3 over 2 divided by a half. Cancel those 2's. So negative square root of 3, and kind of cool because I just needed quadrant 1 of the unit circle. We'll practice with this more in the coming days and get used to seeing quadrant 1 of the unit circle to help you out. See ya.